Hello, this is another module for Energy 101, and we looked at energy in society and why society wants energy and how we use it, and now we're looking at the source for that energy that we extract from the earth in the form of fossil fuels first, and then we'll look at renewable energy sources like wind and solar. So here's the pie chart that we've seen before, looking at where we get our energy. Natural gas that we're going to look at today provides 36% of the total U.S. energy demand. It's the largest segment of natural energy supplies to our society, natural gas. So we want to look at where it's coming from, what the situation might be with natural gas. I'm sorry, I said 36%. In fact, that's on the slide. It should say 26. That 3 is a typo. 26% of our natural gas, of energy, comes from natural gas. So apologize for that typo. That's what we're going to look at today. It's above coal and below oil in the amount of energy we get from it for our whole utilization. So what is natural gas? And by the way, natural gas has essentially no relationship with gasoline. Sometimes there is confusion between natural gas and gasoline. Sometimes we just say gas. Leave off the natural. In fact, most of the time you see it as just a gas. And it's easy to get that confused with gasoline. But when we say gas, if we're using the term accurately, then we're talking about natural gas. And whereas coal is a solid and oil is a liquid, which we're probably already familiar with, natural gas is a gas. It's just like air. It's invisible, and it turns out it's odorless. It has a chemical makeup of carbon plus hydrogen. Remember that coal only had carbon, but natural gas has carbon and hydrogen. We call it a hydrocarbon. We even call coal a hydrocarbon, even though it has no hydrogen in it, but just carbon. So being odorless is a safety issue, and because if you have a leak with your stove and the flame goes out and something happens to the stove and it continues to gas to spew out, then it'll kill whoever's in the room or house, particularly if you're sleeping, if it happens over a long period of time. So we put odorant in the gas so you can smell it. That's for a safety reason. Methane is odorless by itself, but there's an odorant that is added to the natural gas so that we can detect when it's present, since you can't see it or feel it, so that we'll know where it is and know that there's a dangerous situation. As I've already said, it's not gasoline made from oil. Gasoline is produced strictly from crude oil. So again, how do we get that energy out? And all of these hydrocarbons contain what we call chemical energy, and due to the chemical bonding structure, and we release that chemical energy as heat when we react it with oxygen that's in the air. As I've already said, 21% of the air is oxygen. The nitrogen is also there, and it just goes along for the ride. It doesn't interact in any significant way. But when you react oxygen with carbon plus hydrogen, as the natural gas is, then of course the carbon goes to CO2. The oxygen joins the carbon molecule, and the oxygen also joins the hydrogen molecule to produce H2O, which is of course water. So again, CO2 is a global warming gas, the primary one that we worry about, that's increasing in concentration in the atmosphere, and we are afraid that may be causing global warming over the long term. Exactly when and how fast is a difficult prediction, but something we worry about. But due to the fact that some of the energy from burning natural gas comes from reaction with hydrogen, as well as the oxygen, whereas coal has only carbon, the CO2 produced per unit of heat released is about 2/3 for natural gas versus coal. So natural gas is a little better, it's a third better regarding CO2 emissions from a global warming viewpoint. So that's something we'll talk about in more length a little later. But it does have a lower global warming footprint than coal. And you've heard a lot about fracking and how we're getting natural gas these days and how we may have a glut of natural gas, which we'll see how that looks in a few minutes. But the typical vertical well that we always use is shown there with a vertical pipe on the right, and where you just drill a vertical pipe down into a reservoir of sandstone or porous area where natural gas is contained, and it flows up the pipe. And we almost never have to pump it out of the earth. It just flows out of the earth. So it's not like coal where you got to have all this equipment to dig it out and haul it out and put it on rail cars and transport it as a solid. It just flows out, and we put it in a pipeline that we'll see in a minute, and carry it to its destination. So it's a lot easier to handle. But the diagram on the left shows what we're doing lately in the last few years that's allowed us to tap natural gas that is in the earth in what we call shale formations, and that combined with horizontal drilling. Notice that you drill down vertically until you get to a shale seam as is shown there, and then you drill horizontally through the seam so that you can get more exposure and get more of the gas from the formation. If you just drill a vertical well, there would be a very short distance that you'd get out of the seam. You'd enter the seam, and that would produce some gas, and then you'd be out of it pretty quickly because these seams are not very, they don't have very much thickness. So we now can steer these drilling bits and drill horizontally, but it won't come out very fast and not in any productive, economically productive way if you just drill that and wait for the gas to come out in these shale formations. But if you fracture it, and fracking is a term that's been around for a long time, and we've used fracturing in wells for many, many years, and like 40 years at least. I went to a fracking of an oil well up in West Virginia back in the early 80s. It's a huge operation to pressurize this fluid and force it down, this liquid down in there at a very high pressure that fractures the earth and puts cracks in it, and that allows passageways for the gas to flow out of those shale formations and into the pipe, into the well pipe, and up to the surface of the earth. Now the tower doesn't stay there after you've drilled the well and it starts producing. The tower goes away, and it's a fairly clean, mundane pipe coming out of the ground with gas coming out mostly by itself, and just goes into a pipeline, and you do have to have compressors to pump it along the pipeline for long distances. But that's how we're getting the gas out of shale right now. And this is showing the footprint when you're drilling these wells. It doesn't look anywhere like this once they start producing. They take all this equipment away. But it's a pretty complex operation with all the fracking that goes on. You bring in many, many, many trucks and pumpers, they call them, and to pump all this fluid down and put it at high pressure to fracture the earth. So it's got a pretty big footprint while you're drilling the well. And you generally drill a lot of them in a fairly small area to extract all the gas. This is a picture of a typical pipeline. This one's above ground. Some of them are on the ground. Some of them are below the ground. But these are typically 3-4 feet in diameter and go for hundreds, even 1,000 miles, with compressor stations along the way that actually burn some of the gas in gas turbines that drive the compressor that provides the pressure to force it on through to the next compressor station. So it's a fairly clean operation, particularly once it starts producing. Okay, so let's look at the production. So we talk about all the big lift that we've had in the natural gas production. Here's the chart that shows on the vertical scale the trillions of cubic feet per year of natural gas. We generally measure natural gas in terms of cubic feet, and these are trillions of cubic feet. How much is a trillion? A trillion is one with 12 zeros behind it. So it goes thousands, millions, billions, and trillions, going up a factor of 3 every time, multiplying by 1,000. So those are 10 to the 12th cubic feet units. And on the horizontal axis, we see where it shows the production of natural gas from 1900 all the way to 2011. This data goes through the end of 2011. And you can see it built gradually in the 50s as they started developing the infrastructure, and reached a peak in about 1972 or so, and then it fell a little bit and went up in around 1997 or so, but it's been fairly flat at around 17 or so. Only last year did we actually exceed the production that we had in 1972. And you can see the rise there from, what is that, about 2002, 2003, somewhere in there. There's been a fairly steady rise up to where we're now producing about 22 trillion cubic feet per year. So we're getting a rise. Now, you don't produce it unless somebody's willing to buy it. Well, where's the extra natural gas going in the last few years? Well, we'll see the trend in a minute, and where it's all going. But primarily it's been the increased consumption of electric power plants. I talked about the fact that natural gas burns cleaner than coal from a CO2 viewpoint, as well as the fact it doesn't emit any soot that coal produces, that you have to have filters basically to take that out, and you have sulfur dioxides and nitrous oxides that have to be taken out when you burn coal. Natural gas has very little air emissions issues with it. So natural gas power plants has been seeing a real boom, particularly on using gas, particularly for cases where the price is so cheap as it is now. The recession decreased the demand for natural gas in the manufacturing, industrial area, as well as some other areas. And so gas is increasing some, but the prices hit a record low about 2 months ago. It actually fell under $2 a thousand cubic feet. 1,000 cubic feet, about $2 a thousand cubic feet, which is 1 million BTUs if you want to talk in BTUs. We'll talk about units later on. Don't worry about the units, just the relative size right now. And so that just shows where we are. And by the way, how much gas is available? I don't talk too much about the reserves and how much is still available to get. The reason is there's a heck of a lot of speculation. To show how much speculation it is, two of the major entities that in our country that estimate natural gas reserves reduce the reserve estimate, the available resource estimate that's in the earth that we can get out, by 40% earlier in the year. 40% from one year to the next. They actually decreased it. So the shale gas, they decided, wasn't as freely available and as much of it as they originally thought. So it's kind of reminds me of Yogi Berra's quote, "The only time predictions get you into trouble is when they're about the future." It's a difficult thing to predict how much is there. How much of this are we importing? How much of the added to this production? The last slide was U.S. gas production. Well, here's the top of the chart there, the blue, top of the blue area shows the total consumption. But we import some too, that's shown in red. And you can see the imports are actually down from 2006 and down from 2006 to 2011. Some of that has to do with our increased production, and some of it has to do with the recession. But we import about 14% of natural gas, 14%. It's not a huge amount, but what's even better regarding these imports is 90% of this 14% of imports comes from Canada, which is a friendly North American country that we don't have any significant issues with. So energy independence we don't think about as being too big a problem when it comes to importing things from Canada. You'd like to, from a balance of payments viewpoint, not have to import it, but from an independence viewpoint and security viewpoint, and them possibly cutting us off, we don't consider Canada. We consider Canada to be a pretty safe supplier. So 98% of the U.S. natural gas demand comes from North America, about 85% from our own production, and then 14% of what we use coming from Canada, the imports, most of which is Canada. The other countries are very small, very small. So gas utilization, where do we use this gas? Well, we use it in electric power, 34% of it, residential 21%, commercial buildings 14%, and manufacturing industry 30%. And vehicles is 0.1%. I put that on there. We do use some for vehicles. It can be done. There's a lot of infrastructure required and economic issues regarding that. We'll talk more about that later. So that's where we get it and where we get it from, the nature of natural gas, and this shows where we use it in the different segments of our economy. And so again, we've completed coal and natural gas as energy source, discussing those, and next time we'll start on oil, which is a little more problematic and a little more complicated. Thank you.